Good day, my name is John Vincent Saracanlao. You can call me Sir John or Dr. Saracanlao. Good news, the book will be released within this week, uh, second week of February 2024. We're just finalizing the book cover and the back of the book cover, and very positive that it will make changes in my life. Hopefully, knock on wood, for and it's like the timing's perfect, like the start of the lunar New Year, Chinese New Year just started last Saturday, and it's Monday today. So our lesson for today is correlating correlation with simple linear regression. So the previous lesson was on correlation, and now we're trying to correlate correlation with simple linear regression. So this is a person table from which you can do calculation of correlation manually, and this is the formula. So that's the formula. And do I have to discuss it each? No, I don't have to. But you'll see here that the result is 0.966, which is high correlation. And what you'll notice here is the formula for correlation, which is very similar to the formula for M in regression. So here we have summation of x. It is actually the same, and the denominator is just the square of x minus x. So what is regression? How different is correlation from regression? When you say correlation, you just correlate. You just see the relationship. What's the relationship between job satisfaction and performance? And it will indicate if it's positive correlation or negative correlation. It can indicate if it's high, low, and everything. However, in regression, it actually has a predictive value. So regression is a tool used to predict. So and y hat is equals mx plus p. That's the regression equation. So what is y hat? The predicted value of y variable, dependent variable, given an assumption of x, with the condition that there is a positive correlation between x and y. So m here is the same with, you see when you do the correlation table, you're using the same values. You're using 650.4, which is the sum of the square of x minus x multiplied to the sum of the square of x minus y. So this one. So there's a relationship between correlation and regression because it uses the same information. Basically, that's it. And yes, so and this is still, oh, what happened here? 6.4 is the sum. It's the sum of the square of x minus x. So, and the result is 0.9759. So b is equals to y minus mx. So b is 94.9 minus 0.959 multiplied to 83.4. So equals to 84.9 minus 81.39. That's 3.50. That is your b. That's your intercept. Assumed value of x, and m is a coefficient. So y hat is equals to mx plus b. If the x, remember that regression has a predictive value. So if x, job satisfaction, is 85, predicted performance, so m This is your B, that's the formula there, M, and your M is here, that's the result there. So M multiplied to X, what is the value of X? And that's a assumed value, so plus your B. So if job satisfaction is 85, the predicted value for your performance is at 86.46. We're not just correlating, we're actually predicting the values of y given the x using the regression model y equals to mx plus b. That's basically what regression is, not just correlation. So if x is 86, the predicted value of y is 87.43. And if x is 86, yeah, it's 87. 87, the predicted value is 88.41. So the difference between 86 and 87 is 0.975. So that is not 0.975 is actually just your regression coefficient. This means that for every unit increase in employees' satisfaction, there is a corresponding increase of 0.975 in her performance. So from 87 to 86 to 88, 89, as the job satisfaction increase with a given value, there is a predicted value of the performance to be at this point. I hope you understand. In simple terms, we're just giving a specific value of y if x is this, and that is your regression. That is that is how regression works compared to correlation that we just say, oh, there is a correlation. And we say regression by how much? How much does x, what is y if x is like this? So that is technically, in simple terms, what regression is. So there are conditions in regression. Since regression is inferential statistics and we will be using p-value, it requires the data to follow a normal distribution. The data set, the number of data or response should be greater than 200 to set points for the model. So it has to have a lot of respondents. You cannot just use less than 200, less than 50. The model will not, as I've said, it will calculate as based on the example here, but the model is not as not reliable. It's not as specific or correct compared when you have data that are more than 200. The values of codes of y, dependent variable, should be always be equal or greater than the values of or code of x, independent variable, as illustrated below. So yeah, here. So when your values of x, for example, 0 and 1, 0 and 1, that's the point, 0 and 1, and your scores are here, so it should be the same in a sense. You cannot use the values of codes of y should be equal or greater than the values of codes of x, because if your x is greater by value to y, you cannot set the model because the regression model is this line between x and y. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4. So you can set the regression model. This is 0 and 1, 0 and 1 here, and your values are way different, and it reaches to 50. Yeah. as I've said, it will calculate, but it can very, very confusing. So as much as possible, the uniformity between the values, the similarities between the values should be similar. You cannot use 0 and 1 for y, and the values of your x is around 50 to 60 to 100. It will just destroy the model because it cannot find an intercept, and from which the intercept is the regression model or regression line. So you cannot find the connection between the lines. So here, regression Excel note that data is not normally distributed and less than 200, for example. For example, and knowledge and processes only. So for Excel, you click on data analysis and look for regression. And here you have regression. Step 2, you'll have this one. And Y, enter the range. Y, enter the range for the dependent variable to be calculated. And for X, enter the range for the independent variables to be calculated. Can use multiple variables. So click to click check labels and click to check confidence levels and by default and can be changed by choice. So the results in Excel and the results in SPSS. I know this is the result in Excel. So we have R, multiple R, adjusted R square. We're looking at this and this, and that is our coefficient. So I'll discuss how to present that one later. So now we have regression in SPSS. Click Analyze, select Regression, look for Linear, and click OK. Then move variables to move to dependent and independent. So what you're trying to calculate, then you will have this one for your SPSS. The same. Everything's the same, but just a different tool between SPSS and Excel. So for table setting and findings or regression, we are attitudes and reading comprehension. So attitudes and comprehension, that is our X and Y. And we have a regression coefficient of 6.13, a p-value of 1.92, and a probability value of 0.09, which is not significant. So person R is at 0.587. That's person R or multiple R. And our constant is 9.75. 9.75. That's our constant or intercept. And yeah, you can, if you have the book, it would be easier to flip the page. Okay, so we have adjusted R, F value, and significance value. So our regression model is equal to y hat equals mx plus b. So for every unit increase in respondent's attitude, there's a corresponding decrease if it negatively correlated to reading comprehension. So since our correlation is positive, this is a corresponding decrease if there's a negative correlation. So the table shows that the regression model is not significant. As expected, we only have very few data. The null hypothesis is accepted. This signifies that attitude towards reading is not significant to comprehension. How is this so? Simply because our data is not sufficient. We're using how many? Count. We don't have sufficient data, like 200 responses, to really set the regression model. So if you use regression as a tool and you don't fit the conditions, more or less you will have a very erroneous or not completely correct result. So that's one of the things that you have to consider in regression. The conditions that are set are stated in previous pages. So the table shows that regression models are significant. This signifies that attitude towards reading is not significant to comprehension. It is theoretically, but the regression model does not say it is because it didn't fit the conditions from which it should be processed. The regression coefficient at 6.3 shows that for every unit increase in attitude towards reading, there is an improvement of 6.13 in respondents' comprehension. So for every unit increase in attitude, there is a corresponding improvement of 6.13 in respondents' comprehension. There is an increase, but the model is not significant. The value of adjusted R of multiple determination, that's your adjusted R, where's that adjusted R? Here, 0.25, uh, adjusted R, which explains that 25% of the total variation of respondents' comprehension by the variation is explained by the variation of students' respondents' attitudes reading. It means that the 25% of the comprehension is explained by respondents' attitudes towards reading. The remaining 75% is due to unexplained variable. So that's how specific regression as a tool can be, but you have to follow the conditions and the number, especially the number. It really affects the result. So if x, the attitude towards reading is 1.5 and y hat equals mx plus b, so 6.137 times 1.5 plus 9.75, then y hat or the predicted value of comprehension is around 18.96, which is just an estimate. Is it really 18.96? No, it's a theoretical model that it could be based on the regression model that it's by probability it's around 18.96. It's more specific compared to correlation, but it has a lot of conditions from which you can use. Another key result in calculation is standard error, 8.40. The standard error of regression is the average distance of the data points from the regression line. So we have the regression line and the standard error. So the result is calculated with the scores of the dependent variable. For example, the standard error of 8.440 is the average points from the regression line. It shows that the measures of how points is connected to the regression line. Thus, the true value is equals to y hat plus standard error, which is around, so we deduct 8.40 to the estimated score, and we plus 8.40 to the estimated score. So this is the, since it's a standard error, so this is the point, the regression point, and you have your standard errors. So it also calculates that one. So technically, the score is not, the predicted value is not 18.96, but between the score of 10.5 to 27.36. So the lesser the standard error, the better your model. I hope you understand that. So one error, one very significant, rarely used but significant data in correlation is your standard error. So here, there's another condition for out. So we'll end there because I'll be discussing multiple linear regression and their condition. It can be a very, it's just a long topic. However, I would like to remind that it is, which will be discussed later, regression model is about finding the right fit, the right fitting. It's not about using a lot of models, a lot of variables to create to predict a score. So if you have multiple variables, try to minimize it as much as you can because with multiple linear regression, it affects everything. So I strongly suggest when you calculate two variables and you want to predict a model, try to use single variable, one x, one y, simple linear regression. And yeah, but sometimes you have to use more, so that's multiple linear regression. But the important thing is when you do your paper, you're trying to prove something from your end of your study, try to use one. Try to use one because when you use multiple regression, there's a lot of conditions that has to be met, including the conditions that are already stated in simple linear regression. So I hope you learned something today, and I really hope that the book will change my life. And you will purchase the book and you'll learn something from it and you'll practice research, not as something as you do in school, but something that you do to improve the quality of work, quality of their working environment, etc., etc. Stated in the back cover or in the introduction. We're still making a decision about that. So thank you and have a great day.